With that, I would like to introduce our next speaker, who is Christian Posta. As I learned, he's got Hungarian ancestors, and he is a field CTO at solo.io and well known in the community for being an author, a frequent blogger, speaker, open source enthusiast, and committed to various open source projects like Istio and Kubernetes. Today, he helps companies create and deploy large-scale applications. And in this talk, we will be hearing from him about service meshes. Christian, go ahead and have fun.
Okay, awesome. Thank you so much for that introduction. And thank you all for joining my session and for the Craft organizers for having me. I'm going to be talking about service mesh, as this has been an area of deep interest for me for the last 4 years, and generally distributed systems for much longer before that. Sorry we can't be in person, would much rather be in person. I was at the last in-person CraftConf in 2019. This is definitely one of my favorite conferences. Back then I spoke about service mesh. There's been some changes since then, so we'll get into that as we get along with the talk here. But yeah, I'm Christian. One thing I want to point out is that I've been working on Istio in action for Manning now for probably 2.5, maybe a little bit longer, maybe 3 years. During that time, a lot of things have changed in the service mesh ecosystem. Istio changed a lot, was moving very quickly. I moved to a startup, solo.io, back at the beginning of 2019. That took a lot of effort and energy and so on. And as things have sort of settled down a bit, we're finally getting closer to completing the book. So be on the lookout for that. At Solo, so I came to Solo as one of the first early employees to help bring my expertise in this area and build products and open source projects that help ease the pain of adopting, and operating service mesh technology, because I do believe this is the right approach for solving the problems that services have when communicating with each other. So service mesh, what is this, right? I think last time I did the presentation at CraftConf, I talked and compared 3 different service meshes, actually 4, Istio, Console, App Mesh, and Linkerd. Since then, there's been more that have cropped up onto the scene. This is a sampling of some of those. But I guess real quick, if we're going to deploy a service mesh into production, the title of this talk, what is this? What is a service mesh and how does it help me? So let's all get on the same page about that. So a service mesh is intended to solve the application networking challenges that occur when services communicate with each other. So especially as we start going to microservices, there's going to be more communication over the network, especially if we start deploying into cloud platforms like container-based platforms and Kubernetes and all of this stuff. The assumptions of how we built our applications have changed. No longer can we just assume that every application is going to just be available, highly available. The database is available. It's built on Oracle, and it's not going to go down, but it does, and it will, especially in a container and cloud environment. So the assumptions of the applications have to be more defensive. Services will go down. There will be problems on the network. Now, how do we solve this? How do we solve things like timeouts and retries and circuit breaking and client-side load balancing and service discovery and telemetry collection, and do it in a consistent way for an application, regardless of what language or framework it was written in? Kind of like what Docker and Kubernetes did for packaging and delivering applications in a language and framework agnostic way, and Kubernetes came along and manages now these applications across any nodes and starts and stops them and health check and all this stuff without caring whether the languages and frameworks that were written for those applications. Same thing the service mesh is trying to do, solve cross-cutting concerns, application networking concerns for the applications, and it's implemented by putting these functionalities as a little process, a sidecar helper process next to each application. And so the application, when it talks over the network, it talks first through this little helper sidecar. And then the sidecar implements things like timeouts and retries and circuit breaking and all that stuff. right? And if each application, each instance has this little helper process solving those application networking challenges, things are consistent. You're able to get telemetry and understand what's happening between the services. You're actually able to implement things like security and fault tolerance and reliability, this type of stuff between the services without having to jam that into the application code. So the service mesh is made up of these proxies and some way to interact with these proxies, a control plane that solve these types of problems, provide these types of benefits. Now, you might be asking, well, do I need a service mesh? And that's really going to be up to you to decide. So if you're going to a microservices style environment architecture, and you're deploying onto cloud native infrastructure containers, Kubernetes, and so on, microservices becomes extremely complicated when you start putting more and more onto the network, because you can't trust the network. All right? And so now if you're doing HTTP, if you're doing REST and gRPC calls, different languages, different frameworks on containers, ephemerally scaling, deploying across multiple clusters, you'll likely need something that looks like a service mesh. So it might be worth investigating. Things to keep an eye out if you're not there yet, or if you're not in that you don't fall into that set of use cases, then service mesh, you don't need it. Right? There are drawbacks to running a service mesh. Running a proxy next to each instance of your application induces some overhead. Right? There will be some latency and network penalty. What the various implementations are trying to drive that down, but it's still there. Now, you could also argue, well, if I did this inside the application, I'm going to take memory overhead, CPU overhead, latency overhead. So it has to live somewhere. So you can't just ignore solving these problems if you're going to build a microservice architecture. But going in, knowing, understanding what the trade-offs are is important. So things to keep an eye out for. If you're not there yet, or if you're trending in that direction, if you're building a lot of this application networking stuff into the language and frameworks itself, this is not differentiating. Your organization is probably building much more interesting things than level 7 application networking tools. All right, so this is not a differentiating thing for your business, and having to maintain this across multiple language, maybe frameworks, I mean, that's undifferentiating, right? And if you're having trouble, I know I see a lot of people who deploy microservices, they deploy their CI/CD, they got their Kubernetes, everything looks good, and then they get to a point where they're afraid to make changes. They're afraid to deploy new revisions out to their infrastructure because they don't know how it's going to behave. They don't know what kind of impact it's going to bring. And the whole point of microservices is to enable teams to go faster and deliver software faster. But if you're delivering software faster and it's introducing failures, then that's not good. So getting some level of observability, metric collection in a consistent way of what's happening on the network, what's happening between these services is extremely important. That's something you should keep an eye out for. And this is a problem space that service mesh comes in and can help solve the problem nicely. The other thing to keep eye out for is, do you have the supporting infrastructure for this? If you're just deployed all on physical servers and VMs, things are not very dynamic, very static networking and that kind of stuff, maybe you don't need a service mesh for that. You don't have to deal with a lot of the dynamicism that happens in that environment. If you're on Kubernetes, if you're talking to functions as a service, your VMs deployed on cloud, those could be coming and going in auto scaling groups and so on. Then it starts to fall into that category, what might make sense. And there are other ways to get service mesh-like behavior without going all the way to deploying a proxy next to each application instance. And we often see, and I've been working with large organizations throughout the history of my career, but more recently, specifically focused on service mesh and adoption and successfully rolling it out. There's a lot of instances where starting with the edge, starting with lightweight gateways that bring some of the benefits of traffic control, observability, some levels of security that you start off with. And this is an iterative journey. It's not something you just jump right in and adopt fully. So where do you start? Again, I'll say start at the edge, understanding the technology, understanding how the mesh works, but understanding it from a familiar position. We understand what ingress is. We understand what gateways are. Deploying service mesh sidecars and this data plane, all this stuff, that might, let's grow into that. Let's not the services that you're running are providing a lot of business value. When you start deploying these sidecars next to the applications, they become part of the application. So it makes sense from an operations standpoint or developer standpoint or both, that you understand what this data plane piece does, this sidecar does, this proxy. Right? And so starting at the edge is where a lot of people naturally gravitate toward. And I've been recommending this for the last 3-4 years. The next thing is pick a specific high value use case and then iterate. A service mesh might bring, like you saw the slide earlier, a lot of benefits, but focus on 1 or 2 specific benefits for maybe 1 or 2 applications in your architecture and start to show the value and iterate from there. All right, so maybe I see a lot of organizations, they start off with being very interested in mutual TLS, because if the proxy lives on both sides of the connection between 2 different applications, then it can handle transport encryption. The service mesh control plane can handle issuing certificates and rotating certificates and taking care of all that stuff. So if you're a developer, and I use this as an example, I come originally from a Java background, and many times when I was trying to configure the Java key store, trust store, all of that stuff to get the certificates just right, that was a huge pain. And then when you move from development to a higher environment and ultimately into production, and then you find out certain ciphers have been changed and so on between environments, that's such a pain. But now, if you have this sidecar in place in the service mesh, the sidecar can handle encrypting the traffic between services. Excuse me. So pick a specific case, iterate, figure out which data plane, which proxy. So Envoy is an extremely popular sidecar and gateway proxy for doing this. A lot of service meshes have adopted extremely powerful. And if you understand Envoy at the edge, you understand Envoy throughout your architecture. Now, let's jump back real quick, because there are quite a few different service mesh implementations. And when I gave a talk back at CraftConf in 2019, and even in the year before that, because I just joined Solo in the beginning of 2019, it wasn't clear what service mesh you should use, the maturity levels, the trajectory of them, which ones are going to be adopted. Because at that time, people were just kind of talking about it. People weren't actually adopting it, and for good reason. Mostly they weren't ready. And so when I gave the talk, I said at the end that there's going to be a lot of anecdotes, and this one's faster, and this one's slower, and this one's bloated, and this one's not, and so on. But figure out what are your use cases. So like we said in the previous slide, this journey is going to be iterative anyway, but focus on what are your use cases, and then how can a service mesh bring you value? And I gave the same advice. Start with the gateway, at the edge, understand the data plane, iteratively adopt it, and so forth. And at Solo, we were heavily invested in Envoy technology, but we weren't heavily invested in any one particular service mesh. We were actually pretty neutral then. And at the end of that talk in CraftConf, I said, take a look at an open source project that we're working on called Superglue, because what it does is allow you to abstract away any of the details of a specific mesh and focus on getting that mesh running and exposing it to your developers in a much cleaner, much more friendly way. Then you can plug things on top of it and build tooling on top of the service mesh, because that's where the interesting story is, not in this boring networking stuff in the bottom, right? But fast forward since then, Superglue sort of evolved as an open source project into a new open source project called Glue Mesh, and eventually a product that we sell at Solo. But the interesting part about that is from early 2019 to, let's say, the middle of summer 2020, there'd been a big shift in what we saw dealing with our customers. So we came in as neutral, party to assist in certain POCs at large organizations around service mesh. And what we saw at the beginning of the summer in 2020 and mid 2020 was that a lot of people were doing these POCs and these bake-offs and comparing them, and they were landing on Istio. They were going toward Istio. And some other things coincidentally happened in the Istio community. The architecture drastically simplified, the user experience drastically improved, and people were actually taking Istio into production at massive scale. And at Solo, we're sitting here watching this, we're watching the market unfold and so on. And we said, all right, building a tool to abstract away every single service mesh, that's a tall offering, right? But if the service mesh ecosystem is starting to converge and show that, hey, there's a dominant one and maybe a couple other ones that are useful, then we can cut out a big portion of this, the multi-mesh vision or the operational vision that we have for service mesh. And that's what's been happening. So in our observations in the market, Istio has become the dominant service mesh, is deployed in large organizations, small organizations, edge use cases, core use cases, everything in between. And we have oriented our business. So we've changed, we've pivoted to a certain degree toward, Istio as a foundation for products like Glue Mesh and excuse me, products like our API gateway. So, we're a business, right? And we're going to make business decisions, and Istio is clearly one from a business perspective in our observation. But if you go look out at the community, like in February this year at the IstioCon conference, I was on the selection committee there. Great number, 130, 140 different abstracts that were submitted, all high quality. We could only pick 20 or 25 or whatever it was. And if you go look at those talks, it was all end users deploying at massive scale, massive success. eBay, Verizon, T-Mobile, the US government, and so on. Istio has cemented itself. So what I'm going to talk about now is in terms of deploying to production. Now, these suggestions will be universal, you could say, but I'm going to look at them through the lens of Istio. So let's get started. The first one, and one of the most important ones, especially as people are coming to a service mesh, the hello world experience, however nice, simple, and grandeur that it might be, is not a suitable installation for production. And sometimes people forget this. So let me give you a quick example. So I have a cluster here, kubectl, and we don't have anything here. If you go to the Istio website and the documentation and get started, installation and so on, right? You can go through the docs. But a typical getting started experience with Istio is, all right, well, let's istio-ctl install. Right? Yep, I do want to install. So we'll give that a second. That's going to download all of the right container images and deployment manifests and install this into my Kubernetes cluster. And from there, then we'll go, we'll deploy, if you, again, follow the guides, we'll be able to install some sample applications and so on. So like if we do kubectl get pod in the Istio system namespace, what do we have? We have the control plane running. We have a gateway running. The gateway allows traffic. This is an ingress gateway, allows traffic into the service mesh. All right, maybe we do kubectl create namespace Istio in action, and then we'll apply some sample apps. Actually, we need to label Istio in action so that, one second, I messed up. All in namespace Istio in action, right? So Now what we should see is we have our service mesh installed. We'll have our sample applications deployed with the sidecar. I reversed the order, so apologies here for the slight delay here. But that's what the install experience, that's what the initial getting started experience looks like with Istio. Looks simple, but there's some nuance here, and there's a nuance that that we've learned the hard way, and working with customers. So we get pod Istio in action. We should see we have our workloads running now 2 out of 2, which means the sidecar proxy is deployed there. Looks simple. Istio CTL install and then deploy some applications. That's not the reality though. So I'm going to walk you through a couple of things that you should watch out for when deploying Istio for production. The first one is, I'm going to script this part of the demo so we get the steps in order. The first thing, excuse me, that we want to do is we don't want to deploy all the components of the control plane and the gateways and all that stuff. We want to keep them separate. And this is really important because you will upgrade things separately. So if your first step of dealing with the service mesh is installation, you should be thinking about, how am I going to upgrade this thing? Because I will need to. All right, so what we're going to do is we're going to create the Istio system namespace. We're going to actually create an Istio service, Kubernetes service in here, because in certain versions of Istio, there are some gotchas around using a feature called revisions, and I'll show that right now. So Istio CTL install, like we saw earlier, but we're going to use a custom config that specifies we don't want the gateways. We're just going to use minimal. We do want to use some of the DNS features inside of Istio, which is extremely, extremely important for building real production use cases and multi-cluster and so on. And lastly, we're going to use revisions, because when we install a control plane, we want to give it a specific revision, and we want to be able to control it fine grain, what workloads are using what revisions, because it's very important for the upgrade procedure. Right? So this is an example of, well, the documentation says, yeah, Istio CTL install, and then you're off and running. But in reality, you have to think through this a little bit more. So now if I do cube CTL get pod in Istio system, we see we have the Istio control plane running. It's been tagged with a particular revision, and we don't have the ingress gateway running, and that's on purpose. In our Istio in action namespace, one second. I guess I didn't. One second. I did all this work to prepare the demos, and then I didn't actually run. Let's go Istio demos conference. Didn't actually run setup. So we'll give it a second to run, but we're gonna come back to our slides where that setup runs. Right. Okay. So the initial hello world experience is not suitable for production. I know it's probably obvious, but I can't tell you how many times I'm working with folks and there was no care taken in this exact step. Number 2, Istio and other service meshes have some of them have gateway capabilities in their service mesh, some don't, and some you have to bring your own gateway and so on. But the gateway functionality is extremely important for building self-service autonomy for functionality in your service mesh, as well as multi-cluster use cases. Because as traffic flows from one cluster to another cluster, which those may be in different networks, you need some way to validate and authorize the traffic coming into your cluster that is intended to be cluster to cluster versus end user coming into, or ingress use case. So the difference between the ingress use case and the peer-to-peer or cluster-to-cluster use case. And so for that reason, and a couple others that we're actually going to take a look at now in the demo, the gateways are extremely important. And let's take a look at how we would deploy the gateways then. So like if we come here, Istio in action, we should see our sample workloads now. We do see them. There are no sidecars deployed with them yet. Again, a subtle but important point. You don't, if you have running workloads, you know, and we'll come to this in a second, but you don't just willy-nilly start changing and upgrading and rolling out changes and so on to your application. So we'll take a look at that in a second. But when we set up a gateway in Istio, for example, we noticed that in the demo scenario, we saw that the gateway and the control plane were running in the same namespace, and that's just how it was set up. But what we want to do here in a more production-like environment is separate those two out into different namespaces. And the reason for that is in the Istio system namespace, or the namespace where the service mesh control plane lives, there's going to be important config there and likely secrets for administering the certificate authorities and PKI and all that stuff. The ingress gateway might be used by end users. We don't want to give them access to that namespace, a very critical namespace. So and any of the certs that they use for TLS and that kind of thing on the gateway, that should be in a different namespace. So that's what we're going to do here. We're going to we see that we don't have the Istio ingress gateway deployed in Istio system. What we're going to do is create a new namespace called Istio ingress, and then we're going to install that config that we saw up here, again using revisions for the same reason that we install the control plane with revisions. Anytime you install a component for your service mesh, you have to be thinking about what is the life cycle of this thing? How am I going to operate it, and how am I going to upgrade it safely? And we'll get to the upgrades in a second, but we'll give this a second. This is going to install the Istio ingress gateway into a separate specific ingress namespace. All right, so now if I do kubectl get ingress or get pod in the Istio ingress namespace, we see we have our Istio ingress deployed there. What we're going to do now is we'll see that the service was built. Now we're going to use Istio's primitives, Istio's API to expose our service on the ingress gateway. Don't have to worry about the details of this. This basically just says open up port 80 and watch for this host. And then this says when you see this host, route it to a particular workload. And you can see in this case, and this is kind of typical when you start to adopt Istio specifically, but a service mesh in general, that you can use the gateway capabilities first without changing your applications. So we're going to route traffic from the ingress gateway to our applications. But you saw, I'm going to show again here, that okay, get pod and namespace Istio in action. Our workloads still don't have the service mesh sidecar yet. All right, but we just created that that routing. Now, if I try to call it through the ingress gateway with that host in ingress gateway, we can see here. We can see that we get a response to it, the correct response that they were expecting. All right, so that's let me come back to the slides. In this case, setting up, operating the gateway, and so on. But the gateways are extremely important for self-service. Oh, the self-service demo that I'll show just real quick. Now we won't do that. If I go to here and then, so let's say I am, no, we'll do that in a second. Getting too far ahead of myself. All right, so then 5 steps for Istio or service mesh in production. So that's step 2. Step 3, incredibly important concept that kind of gets lost in the noise of service mesh and some of the details. But the data plane, the service proxy, is, and you should consider it, part of your application. So I'll say that again. The data plane implements application networking behavior for your application, and you should think of it as all part of the same atomic unit. Now, if you look at what the proxy of the data plane is actually doing, when a request goes out of the application and through the proxy is acting sort of like an interceptor, and it's enriching the behavior of this network traffic. The idea of interceptors for network traffic is not new. You probably see that in your application-specific RPC libraries, if you're using Spring or whatever it is. Interceptors are a common way to enhance the capabilities of your network, or the calls that you make to the network. It's the exact same thing, except it's running out of process. It's running out of the application, but it's still considered part of the application. So with that in mind, if you're going to deploy a service mesh into production, you have to treat the data plane as though it's part of that application. So when we roll out the sidecar, as you can see, we don't have the sidecar deployed here. And in the demo apps, we did see that, right? Oh yeah, just istio CTO install, label this namespace and put the sidecars there. If you have traffic running to these workloads, what you want to do is you want to slowly and you want to control how you roll out changes to any application at any point. Introducing the service mesh data plane is no different. All right, so in this case, we are going to label the namespace with a label that indicates what revision or what version of Istio to use. And then what we're going to do is we're going to deploy a canary, just like you would with your applications. We're going to deploy a canary of our application, in this case, the Web API canary. And we see that the injection of the sidecar has started. All right, and now if we bring this back, at some point it will come back up. So get pod, Istio in action. We'll see that it does come up. And so we have a web API that's running the original workload, web API that's running the workload, but now with a sidecar proxy. All right, and so now if we take a look at proxy status, we can see indeed this one has a sidecar proxy. It is running version 1.9.5. And what we're going to do is, at this point, when you introduce a canary, you're going to put some load on it. As an example of putting some load, make sure you're not deviating from your expected bounds of what the application is supposed to behave. And if all looks good, then you start rolling out the application, right? You start rolling out the rest of the canary. Istio in action, right? We can see now slowly the web API service has 2 of 2, and the canary has 2 and 2. And then you start to roll this out so that the canary becomes the official production version now, and you take out the other one. And I'm going to speed that up. Yeah, we'll do that. We'll speed that up and just roll it out to all of the workloads. Now, one thing that you'll find with a service mesh is that this sidecar process, this is a very important production scenario. This sidecar process, like I said, is part of the application, but it lives out of process. It's not living inside of the same, so if it's JVM, this proxy is written in C++, it's written as a different process. You treat them the same atomically. But when you deploy them, one of the processes comes up and then the other one comes up, or they both come up at the same time. But if one comes up and the other one doesn't, but it depends on the other one, then that could be a problem. So for example, if the workload process, the JVM, let's say, maybe that's a bad example, maybe the Node.js process comes up and it comes up faster than the proxy. And the Node.js application tries to make a connection out over the network. It won't be able to because the proxy is not ready. And in a service mesh, pattern, the traffic that goes out to the network has to go through the proxy. So what's going to happen? The application is going to fail. And maybe eventually the proxy will come up, but in something like Kubernetes will say, this application is not healthy, restart it. And then what's going to happen? The workload comes up quick, tries to hit the network, it can't because the proxy's not up yet, fail, same thing. And then you just sit in this cycle. And so that's a problem. And so let me see. Oh yeah, hopefully we can get to all of these. What I want to show here is how with Istio, you can solve this problem by saying, hey, start the sidecar proxy first and then start the application. At least in Kubernetes, we're able to do that. So if I come over here on the bottom screen here, and I pick any one of these apps, maybe the recommendation app, I do a describe, and I go take a look at, you know what, let's do this. Let's do this so you can see it better. Describe on recommendation. If we come down all the way to the bottom, what do we see? We see the Istio init container started up. Then we see the recommendation container start. So the application started first. And then the Istio sidecar proxy came up. Now, if this application needed to communicate over the network and it couldn't, this would be a huge problem. So what can we do? In Istio, what we can do is we can configure the sidecars to hold the proxy or hold the application until the proxy actually starts first. Right. So now what we're going to do here is a combination. We're gonna introduce this new functionality. But like I said, in production, you don't just make changes and everything just magically works. What we're going to do is we're going to actually introduce this new change as an upgrade to Istio, which is why we're using the revisions. We're also going to upgrade to a newer version of Istio, and that's just to show the upgrade behavior. But when we use revisions, then we can safely introduce new behavior that the service mesh might bring. All right, so we'll give this a second, and then what we will see, and I might have to speed this up because we're running out of time. Give this a second to come up. What we're doing is we're downloading and installing Istio 1.10. And what we're going to do now is we're going to label the namespace Istio in action with the new revision. And then we're going to deploy a canary version of our app, just like we did in the previous step. If we take a look at the proxies that are being used, oh, we don't see it yet. I was going too fast. So we give this a second to come up. What we'll see is proxy status. Oh, still not coming up. Oh, all right, starting to come up now. It's just a little bit slow for some reason. Proxy status, still, what? This is running a little bit slow. It's all running kind on my cluster here locally, and maybe my laptop is time for a new laptop. All right, now we're coming up. Now it's running. So now if we run status, we should see that this new version is running 1.10.0. All the other ones are still in the previous version. Everything running safely. Now, if we run our canines and go take a look at the canary, we do a describe on that. If we come down here, we'll see eventually that the proxy started first, and then the application container started next. So Istio configures the pods to do this so that you get safer behavior when you're deploying your applications in production. So I'm running out of time. The last thing I'll do is I'll show you that just like all the premises in the previous 3 steps, that, just deploying things out based on the hello world guides are not production ready. Same thing with certificate management in a service mesh environment is not production ready. There are steps that you can and should take to secure the secrets, integrate them with your existing PKI, like maybe Vault. And I have a demo for that, but we're going to skip it for now. Reach out to me afterward. I'm happy to talk to you more about this. And then lastly, this is such an important, I've tried to point this out a little bit throughout the talk, but if you're going to take the service mesh data plane and put it into your apps, you have to understand how it works, how to debug it, how to operate it. It's crucial. You can't just say that, oh, well, this particular service mesh, it doesn't ever have any problems, so I'm just going to deploy this random proxy. And that's not going to work because you will have problems. Networking is not easy. You'll see keep alive issues, 503s for no reason, connection load balancing not happening the way you need. So understand the data plane. Envoy proxy is being used by a lot of the service meshes. So if you understand Envoy, for example, you'll understand it across any of the service meshes. This is, you can't understate this. Again, the data plane, the sidecar proxy is part of the application. Now, unfortunately, I won't be able to do this workshop for you all at Craft, or I didn't get the chance, it didn't work out. But we do have some hands-on workshop material, and I encourage you to go take a look. We just ran one in Europe yesterday. Unfortunately, we'll continually do them. We'll run another one in North America, I think the middle of June. And we'll run another one in the Asia Pacific area in the end of June, early July, I believe. So go to the events webinars page on solo.io and you can take a look at getting deeper into how you run Istio in production. Some of the material from this talk is based on that. So with that, I'd like to, I think I left 3 minutes for questions, but please reach out to me. I post my contact information here specifically for that reason. I'm heavily engaged in the community. You'll find me on the Istio Slack. You'll find me on the Solo Slack, on the Kubernetes Slack. Yeah, happy to take questions, and thanks for any of you that joined, and hopefully it was worth your time.
Thank you for the great talk, Christian. Yeah, we have a couple of questions at this point, if you don't mind. First one is, do you feel that you need a specialized team to work on service mesh rollout in a company?
So we are working with quite a few organizations right now around the world. Some of them deploying service mesh at probably the largest scale compared to anybody else. And the approach that we've taken is each individual team and every part of the organization, they kind of want to have some level of autonomy, right? But you need to start off with just like with any other technology adoption, right? It's iterative, and you got to have some folks who are able to champion and lead the effort and disseminate the information to the rest of the teams to grow some of the expertise and so on. Now, some of that championing and so on should be aimed at education and that kind of thing. The other part of that really should be aimed at building architecture and automation into your platform so that the end users don't have to be experts in Istio per se. They have to understand what the data plane is doing and what's happening on the data plane, how to influence that. But they don't have to be operator extraordinaire at Istio per se. So finding the right balance, finding the right automation, and how to scale that out into your organization typically starts initially with a small team who can evangelize and drive that, as well as, at Solo, this is our area of expertise. No other company in the world that has the level of expertise that we do in driving adoption of production, service mesh, Istio deployments, Envoy deployments. So doing it with a partner doing it with me is worthwhile.
Well, thank you, Christian. Let's go for one more question, I think. Matthias is asking, what do you think is the worst drawback of using service mesh?
The worst drawback is when you throw it into your architecture haphazardly without understanding it and architecting it correctly and finding out that it, just like any other technology, any other middleware, any other networking dependency, if you don't do it right, it can take down your applications. And so again, this goes back to the point number one that I made, that the getting started experience, some of the other service meshes, they differentiate themselves by saying, oh yeah, we're so easy, we do this. None of this is easy. When you deploy and you follow the happy path, hello world, that looks easy. But when you put it into production, your applications won't either already have hidden issues and they just haven't surfaced yet, or they won't behave nicely with some of the nuances of the service mesh, some of the things that I covered today. So without planning ahead and actually thinking ahead about how this will impact your applications, you could end up in some serious trouble. This is a critical piece of your infrastructure. So I would definitely advise, look past the hello world BS and actually deploy it in a real environment and watch out for some of the potholes for doing that.
It's completely fair. All right, I think we're out of time now. Christian, thank you for the fantastic talk.